This is a lesson on how to find parallel lines. If you're given an equation, you first must find the slope of that equation, because parallel lines have the same slope. So if I looked at this equation, I know that 3 over 2 is the slope. So I'm simply going to take that and put it in my other equation, which, generally speaking, most teachers would be okay if you put it in slope-intercept form. I would be for now. And what we're going to do is we know that 4 is the x value, and we know that negative 3 is the y value. So we're going to go ahead and substitute those values in. It matters where they go. So again, the negative 3 goes in for the y, and the 4 goes in for the x. We have one variable left, it's b. We're going to solve for it, and then we'll just rewrite our equation. So we're going to say negative 3 equals, we do 3 halves times 4, so it's either 12 over 2, which is 6, or you can reduce. Either way, you should get 6, plus b equals negative 3. And since we still only have one variable, we're just going to subtract 6 from both sides. And we get negative 9 equals b. So we're just about done. We just have to plug those values back into our equation and say, hey, we know the slope has to be 3 halves. And we know the y-intercept is negative 9. So there's the equation of the line parallel to 3 halves x plus 8. If we had something different, so let's say we had this line, and we needed to have the equation parallel to that through 3, 1, we would need to either know a lot about this. We could convert it to slope-intercept form and find the slope that way. I know a shortcut to finding the slope in this form. It's negative a over b. So the opposite of a divided by b. So the slope of this line is negative 3. So if I'm looking for a parallel line to that, I know it's also going to be negative 3. And the process, if you're looking for slope-intercept form, is going to be identical to the previous one. So we know we're going to plug in the 3 in for the x. We're going to plug the 1 in for the y. And we're going to solve. It's 1 equals negative 9 plus b. I'm going to add 9. I'm going to add 9. 10 equals b. So that just means that we have y equals negative 3x plus 10. Now there's another trick that you can do here. If it doesn't matter what form the answer is in, if you know that you're looking for parallel, then you know if you keep the 9 and the 3 exactly where they are, the same signs, then the slope is not going to change. And then if you plug in your 3 in for x and your 1 in for y, you'll notice that you only have one variable left, and that's the c. So if we solve for c and then we write the equation, 27 plus 3 is c, c must equal 30, right? So then I can rewrite the equation as 9x plus 3y equals 30. And these are equivalent equations. They are the same exact line in different forms. We'll do one more for good measure here. Let's make it a little more challenging. Let's say we had a couple points. Let's say 3, 5 and 8, 2. Okay. And we wanted to go through this point, but parallel to the line that passes through those 2 points. So first we find the slope of those two. So I'm going to say that from 5 to 2 is down 3, and from 3 to 8 is up 5, and that is the slope that I need. So y equals negative 3/5 x plus b. plug in my 8, plug in my 2, and this looks like it might be a little ugly at the fractions, but I like those. So it's 2 equals negative 24 over 5 plus b. And what I like to do is I like to make this 2 into 10 over 5, which then I'm going to add 24/5 to both sides and get 10/5 plus 24/5 is 34/5. That is my b value. So then my equation is going to be y equals negative 3/5 x plus 34/5.